Hi everyone and welcome back. Welcome to my YouTube channel, and here we are covering all about microservices, and we are talking about videos related to serverless framework and how we can use Nest.js to build our serverless framework with the CDK. So in the last video we were able to deploy Nest.js application as a Lambda, and in the further videos we are going to play a lot with the serverless framework, serverless architecture components and Nest.js app, where Nest.js will be acting as a Lambda, independent Lambda, dealing with the S3 buckets, SNS, SQS, Event Bridge, API Gateway, and all. So in this video, we wanted to understand what is the primary role. Like we are talking about that we can build the whole microservice architecture with the serverless architecture, right? Earlier you might be having your microservices deployed to Kubernetes, and let's say you wanted to migrate or you wanted to use serverless framework. So in that case, because serverless has these specific components, API gateway, Lambda, DynamoDB, S3, SNS, SQS, Event Bridge, so how you can leverage, how you can transform your architecture into that. So our main agenda will be behind that only. Let's say in this example we are having couple of services. So every service is accessing DynamoDB, and these lambdas are being invoked through API gateway. Either you can have a individual API gateway for the lambdas. These lambdas are uh, acting as a microservice, product microservice, basket microservice, ordering microservice. Either you can have a different API gateway pointing to these different lambdas, or you can have a proxy mapping from this API gateway only. Okay, all the product calls will go to the product lambda Nest.js microservice. All the basket API calls will go to the basket Nest.js microservice. All the order related path based calls will go to ordering microservice. So in this is the end goal we are building. We are building microservices, and we are using API gateway, Lambda, DynamoDB, all these components. So this particular stack looks simple. Here what we are using, a Lambda, API gateway, and DynamoDB. So this architecture looks very simple. We have just API gateway. API gateway will send a request. It's like a request response. Everything is synchronous, right? Lambda will do the read write to the DynamoDB. A very plain and simple architecture. But when we talk about microservices, all the architectures are not that simple. They are doing lots of asynchronous things, lots of events, triggers, cron jobs, background processing. All those things keeps happening. So how we can fit all those things with our serverless architecture components? So that is the thing which we are going to discuss. So in serverless, these are the ways, these are like different categories. APIs are represented by API gateway, data layer, like how you are storing your data, RDS, or you can use DynamoDB, Aurora, same as RDS, and AWS S3 for object-based store. Whenever there is an integration of microservices, either synchronous and asynchronous, like particularly for asynchronous communication, where you want to have an event-driven architecture, where you send an event to a one service, and that service will, like you send a request, HTTP request, okay, create order. So Lambda will handle it. Now Lambda will send an event to either Event Bridge, SNS, SQS. There will be a listener Lambda which will act on to that. But these both the lambdas, the listener lambda and a subscriber lambda, the event generator lambda, which is like creating the event, and the another lambda is the listener subscriber lambda. Both are unaware of each other. They are like totally decoupled architecture. This is how we achieve the event driven architecture, where we are emitting the events and there are listener services or listener lambdas listening to that. And this is how, so integration layer, business logic layer, where we are actually executing the code, either lambda or step function. And this is really important because the invocation part we have divided into three different sections. So you might remember that this is how we are invoking our lambda. We just hit a request to the API gateway, and it's always request and reply. We are sure that we are going to get response back from the lambda because this is how it is designed, request and response. But these are divided into three different categories. All the serverless event triggers are divided into three different categories. Because why I always use event trigger? Because Lambda is just a function. Lambda will invoke itself when there is an event coming to it, and that event may come from the API gateway, from CloudWatch, from the S3, SNS, SQS, from any AWS service, right? So that event is nothing but a JSON payload. Okay, API gateway is saying, okay, user is requesting you the API v1 user endpoint, and this is the payload. So that is the event for Lambda. Lambda will see, okay, I have a Nest.js microservice and router. I will see what needs to be done, and it will send a response back. So first is a request and reply. So all those things you can, Lambda can receive a request from API gateway. ALB can directly hit Lambda, CloudFront, Cognito, S3 bucket. So this is a synchronous invocation where we are sending a request directly to the Lambda, like API gateway, HTTP GET request going to the Lambda, and Lambda will reply back. It's like a request and response. And this particular picture is from Awesome Cloud. I got it from Medium, owned by Ashish Patel. Now, the second type of integrations we have is with the asynchronous invocations happening. So how are these things happening? It can be something like this. Okay, you got a request, okay, and you are able to reply back to the API gateway, but you also need to do some background processing, like you want to generate some event. So you can write some events to the SQS, you can write some event to Event Bridge, you can write event to SNS, SQS, or all these integration platform. So what will happen is there is already, when you write in this way, there will be a listener service. You can attach a Lambda who is going to listen whenever there is a new event in the SQS, when there is a new event is coming from the Event Bridge or SNS, SQS, Event Bridge, all these platforms. So Lambda can listen asynchronously to these platforms. What happens is Lambda is being invoked when the request is coming to the API gateway. So that's a synchronous event, but the asynchronous execution happening through these integration platform, Event Bridge, SNS, SQS. So whenever there is a message on the SNS topic, the Lambda should be able to read that and get that. And then you can also have a retry mechanism. Okay, I will try 3 times because it's a fire and forget. I'm not going to notify the sender back, okay, what is the status? So let's say I got the request from API gateway. This Lambda has created an order and it needs to do some processing. After creating order, let's say sending emails and all. So Lambda will asynchronously send the event to the SQS, and then there is another Lambda listening to that. So whatever the code execution it is doing, this can be totally asynchronous, right? It will maybe retry until unless it is successful. Maximum retries are 3, and then it will die. It won't notify this Lambda, okay, I failed executing your stuff, right? That is asynchronous execution, and it is totally decoupled. This may be a one Nest.js microservice, and this can be another Nest.js Lambda listening to those particular events. So these are divided into these categories. Lambda can be triggered through the Event Bridge events. When the Event Bridge receives an event, SNS receives an event, or S3, we configured one event like, okay, whenever we create a new object on the S3 bucket, this Lambda will get triggered. So Lambda is nothing but a trigger. It can be triggered synchronously, asynchronously, or through poll-based invocation, like through streams. There is a change in the DynamoDB stream. Get, put, update happens on the DynamoDB table, and I wanted to read it through the Lambda or want to do some processing. So that is poll-based, and SQS is also a part of that. SQS, we can just consider that in falling in both the category, asynchronous and poll-based. I mean, both are asynchronous. These are just like 2 different categories we have created. So like SNS Event Bridge. So Lambda will get invoked automatically. I mean, there is no API gateway coming. Lambda will get invoked automatically whenever, but Lambda has to attach itself. Lambda, we need to specify, okay, this Lambda will be listening to the S3 events. This Lambda will be listening to the SNS event. So whenever there is SNS new event available in the SNS topic, Lambda will get triggered. We need to subscribe to these events, S3 events, SNS events, or Event Bridge events. So automatically Lambda will get automatically triggered. So that is another integration platform and microservices needs it very much. So we use these SNS SQS Event Bridge for building the event-driven microservice architecture, and we can do lots of things. There can be a cron schedule happening, and Lambda is getting executed based on the cron. Lambda is reading and writing to the DynamoDB and again dispatching the asynchronous jobs. So everything is possible through these fixed set of components which we are doing. And the target of my discussion is only all about this. We should be able to use this Nest.js service, currently this is a microservice Lambda. This Lambda, which is built in Nest.js, is exposing REST interface. But there can be a Lambda which is just a function and listening to the SNS events, right? This Lambda might be sitting here and you are submitting some events when user is interacting with your Lambda through API gateway and some request, okay, create account, create profile, and then I will send an event to SNS, and then there will be a listener Lambda which is subscribing to all these events and reading it there. So here this Lambda will get invoked, and Lambda is nothing but just a function which might be reading, writing to DynamoDB, RDS, and all those things will be happening here. So same thing can happen through SQS, can happen through the event bridge. And Lambda doesn't need to always associate itself with the API gateway. API gateway when we need to expose a REST interface through Lambda. But Lambda can exist independently, which can do some background jobs. When S3 gets a new object, you update an object, you delete an object, you create a new object in the S3 bucket. So Lambda has its independent existence. It doesn't need to always associate with the API gateway to expose REST interface. They can exist independently and they can do lots of things like, okay, cron schedule. You are running a Lambda every day at 11, which is checking some data and sending email to your clients, right? So here you don't have any API gateway or any exposed interface, but it's part of your whole product where you have these event-driven mechanism and event-driven services. So that's it. So in the next video, what we are going to talk about is we will talk about these use cases with the help of Nest.js microservices, dealing with all these integration components of AWS.